GH101. For the next couple of videos, we're going to be looking at a few more classic beginning programming tasks, and we're going to kill two birds with one stone, and we're also going to talk a little bit about algorithms. I'm going to go up to the Computing Bootcamp in the notes. So I added a section in the Computing Bootcamp algorithms. All right, so an algorithm is a precise way to solve a problem. We need to talk about problems. A problem that we would like to solve, a task. All right, so we'll look at two classic ones. We have a list of numbers, and we want to sort it. So let's say that our list of numbers could be, so our input, the data that we have, 5, 2, 4, 1, 8, 6, 3 maybe. All right, and then the desired output, we want to go ahead and put this into sorted order. So that would be 1, 2, 3, 4, 5, 6, 8. All right, how do we do that? So I'm going to go ahead over to R and start taking some notes here. I'm going to start a new R script that will eventually do this task for us. So I'm going to save this as, I'm going to call this bubble sort, because that's what we're going to do eventually. And I'm going to put up here bubble sort program by me. All right, so first we're going to have some notes on sorting. Okay, so if we have a list of numbers, let's say that these are our numbers. We have let's just say we have these numbers. So take a minute and think about, suppose this list was thousands of numbers or millions, right? So if you had thousands or millions of these numbers, let's say they're all written on paper, how would you sort them? Okay, so pause and think about, this is a small example, but if you had thousands or millions of these, how would you actually go about sorting them? Okay, so pause, think about it, and then maybe write down your algorithm. Okay, you paused. Now I'm going to go through and give a few of the most common sort of easy ways to do this. So one thing to think about is, if I have this, then I want to pick out the smallest. I could look through all the numbers and pick out the smallest. So I'll call this the pick out the smallest algorithm. And the actual name for that is selection sort. All right, so the algorithm here is, I'll write it like this. So go through the list of numbers, find the smallest, put it in front. So if I was using this as my input data, I would go through, find the smallest, that's this one, put it in front. So I would either put it like this and take it from where it was, so just put it on front and everything slides over. A slightly smarter thing to do is to just switch this one with the one in front. Or say swap it. All right, so I'm going to put the 5 here and the 1 there. Okay, so that's what we started with this, and now I have that. All right, that'd be the first step. Note that, okay, so I'll go one more. So what would I do next if this is what I'm trying to do? A reasonable thing is to take the numbers there and find the smallest out of that. So find the second smallest. That's the smallest except for the first. And then put it in the second spot. And we'll swap it. So let's see what that would look like. So that's what I started with, and this is what I'm going to go to. I want to find the second smallest out of all this stuff, which is 2, and then the 2 is already in the right place. Okay? I'm going to say here, repeat with third smallest, fourth smallest, etc. So that is the smallest except for first 2, and then when I get to the fourth, which we'll see, smallest except for first 3, and so on. And why don't I put here, I'm going to say there's an extra space to show the ones that are already sorted. So we know the 1's the smallest. After we look for the second smallest, we know the 2 is good. And then I want to go for the smallest out of the rest. So the third smallest in the list will be the smallest out of here. That's a 3. What should I do? I want to swap the 3 to put it where it's supposed to be. And then I'll put my extra space to say that these ones are already in order. Okay, then the fourth smallest. So what's the smallest out of these? That's 4, so we switch 4 and 5. And then we go for the next one. Smallest out of all of these is 5. That gets switched with the 8. All right, the next one we want to find the smallest out of the last 2, which is the 6. It's already where it's supposed to be. So we'd have it like this, and then we'd only have the 8 left. All right, so this is called selection sort, and you can, the sort of basic idea is pick out the smallest and put it where it's supposed to be. All right, that's an algorithm to solve the sorting problem. So I could give you a list of unsorted numbers and ask you to write down what happens, which would be this here, as you run selection sort. All right, you should think this is kind of cool, that you could, this algorithm is precise enough that we could make the program do this. We can make the computer do this. If we had a list of numbers, you could write this in R code. I'm not going to ask you to do that, but we could write this in R code to make this happen. And it would be kind of like your algorithm for addition or multiplication. It's very mechanical. All right, so that's one way to go. I'm going to give you a different algorithm that is a little bit easier to code, and we're actually going to see the code for it, and it's called bubble sort. Okay, so for the bubble sort problem, the basic idea is compare pairs of numbers. Let's see, compare side by side and swap. All right, and I'm going to show you how we do this before giving the the algorithm. So this here is kind of like an algorithm description. It's not code, it's not even really pseudocode, but it is enough of a description that you could run through it on paper. All right, so for bubble sort, what I'm going to do is I'm going to go through the list and look at each pair. So this pair here, are they in the right order? They're not in the right order, so I should switch them. So I switch them like that. All right, then I want to consider the next pair. 4 and 5, are they in the right order? They're not, so I should switch them. All right, then I can consider the next pair. Are they in the right order? They are not. I should switch them. Then the next pair, are they in the right order? And this is just compared to each other. It is correct. 5 is less than 8. So leave them alone, then go to the next pair. Are these ones in the last order? They are not in the right order, so we switch them. Then we compare the last pair. 3 is less than 8, so we switch them. So let's say something about the algorithm. So we compare first two numbers, swap if out of order, compare second and third number, swap if out of order. I'll also say it one more time, so compare third and fourth numbers, swap if out of order, and then I'll say etc. to the end of the numbers, right, until we've done this all. So that's this, we've done it once. So the claim is that if we just keep repeating this, repeat the following as long as we make some swaps. I'm just going to space these over to say this is what we would be repeating. Okay, so I go through the list, check all the pairs. If I make any swaps, then I keep going. All right, so the next time, I just want to do the same exact thing again. And why don't we say pause, and you do it on paper or on your computer or something. If I go through just like I did the first time, if I go through again, what is the list going to look like after I do that another time? All right, maybe you did it, but let's see. I'm going to go a little bit quicker now. So 2 and 4 are in the right order, leave them alone. 4 and 1 are out of order, switch them. 4 and 5 are in order, leave them alone. 5 and 6 in order, leave them alone. 6 and 3 are in the wrong order, switch them. And then 6 and 8 are okay. So that would be going through another time. We did make a swap, 2 swaps, so we do it again. 2 and 1 are in the wrong order, so switch. 2 and 4 in the right order, leave them alone. 4 and 5 in the right order, leave them alone. 5 and 3 in the wrong order, switch them. 5 and 6 are in the right order, leave them alone. 6 and 8 in the right order, leave them alone. We did make a swap, 2 swaps. So we do it again. 1 and 2 are in the right order, leave them alone. 2 and 4 are in the right order, leave them alone. 4 and 3, wrong order, switch them. And then all the other pairs that we compare are okay. All right, we did make a swap, so we go through again. And this last time we go through and nothing will be swapped, everything's okay. All right, so I could give you a list, and there's two different ways that you could solve this problem, which is pretty cool. You could do it the bubble sort way, or you could do it the selection sort way. And there's actually dozens of other ways that you could do it. And some of them are better in different ways than others. I'm not going to talk about that in this video. So I think that's it for talking about the algorithms. I'm going to do code in the next video. I just want to make some notes. So see the bubble sort.r file, and this will be in the usual place where I keep things for this class. I'll put it in here when we're done with it after the next video. So we have two algorithms, bubble sort and selection sort. So you should be able to do either one of those with a given list of numbers. You should ask, so properties of algorithms, how long does it take? Is it always correct? How much memory does it need? Which types of input data is it better at? These are all questions if you have an algorithm you want to ask to evaluate whether it's a good algorithm or not. How long does it take is called the running time. Is it always correct? We call that the correctness of the algorithm. How much memory does it need? This is called the space or memory. It's also called space. Okay, so these are the types of questions that we would want to ask about an algorithm to decide which one's better, bubble sort or selection sort. I'm not going to answer those questions right now, just to get you thinking. All right, so we'll end this video. In the next one, we'll actually do the code for bubble sort.